Good morning, dear students, and welcome back to our online classes. We are doing chapter number 6, electrolysis. And through our previous classes, we have learned about uh, electrolysis, electrolytes, strong electrolytes, weak electrolytes, and we also learned electrolysis of acidified water as well as electrolysis of molten sodium chloride. Now, in our today's class, we are going to understand about the electrolysis of one very important electrolyte, that is aqueous copper sulfate. The electrolysis of copper sulfate solution means there is water, using platinum anode. Please note, boys, the nature of electrode. Here we are using platinum anode. Platinum is inert electrode. Platinum anode and copper or platinum cathode. So the important thing is over here, you have to remember anode. Anode is made up of inert metal, that is platinum, and cathode can be made either of copper or platinum. It can be active as well as inert, but anode has to be inert, platinum. Okay, so this is one very important condition. Now in the diagram it is very clear that this one is anode, which is made up of platinum, and cathode can be of platinum or it can be of copper. Now the electrolyte which we are taking over here is aqueous copper sulfate solution. So now let us see. Now in this I would also like to add, now to this aqueous copper sulfate solution we can also add some amount of concentrated sulfuric acid to increase the conductivity of the electrolytic solution. Okay, but the electrolyte is mainly made up of copper sulfate and water. Now let us see how the electrolysis takes place and what are the different reactions at the two electrodes as well as the products formed at these respective electrodes. Let us try to understand these things. So electrolysis of copper sulfate solution using platinum anode. Now first let us see what are the ions present in the electrolyte. Now when copper sulfate, this is an ionic compound, so it will dissociate to form cuprous ion, Cu+2 plus sulfate ion, whereas water ionizes to produce H plus ion and OH minus ion. So we have two types of cations. They are copper ion and hydrogen ion. We also have two types of anions over here, sulfate and hydroxide. So now we have to use the reactivity series of cations and anions to understand which ion will get discharged at the electrodes. Now if we see over here, if we take the cations, copper and hydrogen, now in the activity series or the reactivity series, copper is lower in position compared to hydrogen, which means that copper will be more easily displaced towards cathode. Remember cation CC relation, cations will move towards cathode. So at the cathode, out of these two cations, which cation will be discharged? It is Cu+2. So Cu+2 ion will move towards cathode. So this cation is short of 2 electrons, therefore it will gain 2 electrons at the cathode, and it will convert into neutral copper atom, and this neutral copper atom gets deposited at the cathode. Okay, now what type of reaction is this? This is gain of electrons, Gr. So Gr is reduction, gain of electrons. Now let's go to the anions. Now we again have two types of anions, and according to electrochemical series of anions, hydroxide ion will be more readily displaced compared to sulfate ion, because hydroxide ion is at the bottom of the anion series. Therefore, at the anode, hydroxide, both the ions will move towards anode, but which one will get displaced? Hydroxide ion will get displaced. So now we know when one hydroxide ion moves towards anode, it has one excess electron, so it will lose one electron and will convert into OH. Now I have already explained how this OH and OH gets combined. Okay, we have to do this step by step. There will be 4 steps, so I'll do it once again over here. So another hydroxide ion also moves towards anode, releases one electron, converts into OH. Okay, in the same way, another hydroxide ion comes and converts into OH. Another hydroxide comes and converts into OH. That means 4 hydroxide ions move toward anode, and they all one by one lose electron, producing OH. Now these 4 OH will now combine with each other. I'll write, instead of 4, I'll write this in this way: 2OH plus 2OH will combine to form water, and oxygen will be produced. Always remember, when hydroxide ion gets discharged, the product will be oxygen. Okay, so at the anode, which gas will be produced? Oxygen gas will be produced. So these are the reactions taking place at the 2 electrodes, and this is loss of electrons, so it is LO, so oxidation. Okay, now finally what we can conclude, that the electrolysis of copper sulfate solution using platinum anode and copper or platinum cathode produces copper at the cathode, which can be which we observe by the color of the deposit, the reddish pink or reddish brown deposit of copper at the cathode, whereas oxygen gets produced, liberated, at the anode. So this is the electrolysis of copper sulfate solution using platinum anode. Now let us see another electrolysis of copper sulfate solution only, but this time using copper electrodes. That means both anode and cathode are made up of copper. So our both electrodes are active electrodes. Okay, so difference between these two electrolysis is, in this we are using one inert anode, and the cathode can be inert or active, whereas in this particular electrolysis we are using active electrodes, both anode and cathode, and it is made up of copper. So I'll show you the diagram of the electrolytic cell also. So in this case, anode is also made up of copper and cathode is also made up of copper. Well, the electrolyte that we use is same. It is aqueous solution of copper sulfate, and we can also add some amount of concentrated sulfuric acid to increase the conductivity of the electrolyte. Now let us see the ions present and the reaction that takes place in the 2 electrodes. Again, we have the same type of ion, copper sulfate produces copper ion and sulfate ion. Water ionizes to produce H plus and OH minus ions. So the ions are same, 2 types of ions. Now let us see the reactions taking place at the cathode. Now at the cathode, cations will move towards cathode. Now we have 2 cations. Again, out of these 2, copper will be more readily discharged, so copper gets discharged at the cathode. It has 2 less electrons, so it will gain 2 electrons and will convert into neutral copper atom, which can be observed as pink or reddish brown deposit at the cathode. So this is again gain of electrons, so this is reduction. We always have to understand that at the cathode reduction reaction takes place. Now let us see what type of reaction takes place at the anode. Now what type of ions move toward anode? It is negatively charged ions, anions. So over here we have sulfate ion as well as hydroxide ions. Now both the ions migrate towards anode, but according to electrochemical series, which one gets readily discharged? It is hydroxide. Now what type of reaction can we expect at anode? It is loss of electrons. So at the anode, loss of electrons take place. Now we also have to remember that anode is made up of copper. So I'll take another paper to show you. So copper electrode is made up of copper. So this is made up of copper. This is anode. Okay, and towards this anode, we know hydroxide and sulfate ion gets discharged. But hydroxide ion, these two moves towards anode, but hydroxide ion can be readily discharged. So hydroxide ion is more preferred to get discharged at the anode. Now what does this hydroxide do when it reaches anode? It loses electron and converts into OH. This is what is the expected reaction. Okay, now hydroxide ion releases or loses electron, and this lost electron has to be accepted by anode. Okay, otherwise hydroxide ion cannot lose that electron. There has to be someone who can receive that lost electron, and in the electrolytic reaction the anode receives the lost electron or donated electron by anions. Now this is the expected reaction, but let's consider this now anode. Now anode is made up of active metal, which is copper, and copper is a metal. And what is the nature of metal? Does metal lose electron or does metal gain electron? Now the nature of metal is metal always loses electron and converts into cation. Metal never receives electron from others. They always donate electron to others. Now this hydroxide ion, when it comes to anode, it wants to give electron to anode, but since anode is made up of copper, this copper does not receive that electron, because copper's nature is not to receive that electron. Its nature is to give electron to others. Therefore this hydroxide, although it comes towards anode, it cannot lose electron over here. Okay, it does not undergo oxidation over here. Instead of hydroxide ion or sulfate ion undergoing oxidation over here, the anode itself, anode is made up of copper. Copper itself will lose electron. It will lose 2 electrons because the valency of copper is 2. So the anode, which is made up of copper, this itself will lose electron. It undergoes oxidation and converts into copper ion. And this copper ion now comes to the solution. From the anode, this copper ion gets released by the loss of 2 electrons. It gets released as copper ion and gets mixed up with the electrolyte. So what product gets formed at the anode? We don't get oxygen at the anode like the earlier electrolysis of copper sulfate. Over here we get copper ion being produced at the anode instead of oxygen gas, and this copper ion gets mixed with the electrolyte. Now this copper loses electron as long as the electrolysis reaction takes place, and with the passage of time this copper electrode anode becomes thinner and thinner and thinner due to oxidation reaction being taking place over there. Therefore it becomes very important to replace the copper anode with the passage of time in order to continue our electrolysis reaction, because with the passage of time the anode becomes thinner and thinner, and as a result of which the electrolysis reaction becomes weaker and weaker. So in order to continue our electrolysis reaction, the anode made up of copper needs to be replaced from time to time. But in the solution the copper ion will always remain there. The number of copper ions will not become less, because although we saw over here, although at the anode copper ion gets converted into copper, the copper ion which is of electrolyte gets converted into neutral copper atom. That means the number of cation gets decreased due to reaction at the cathode, but same number of copper ion gets formed from the anode. Therefore overall in the electrolyte the number of copper ion remains same, which can be observed by the color of the electrolyte. The blue color of the electrolyte never fades, whereas in this electrolysis reaction, the blue color of the electrolytic solution fades with the passage of time, which shows that the copper ion is being removed from the electrolyte and being converted into copper. Okay, so the two differences between these two reactions which we can observe is the blue color of the electrolyte fades with the passage of time in this particular reaction, electrolysis, whereas in this electrolysis the blue color of the electrolyte remains intact. Am I clear, boys? Now let us write the reaction taking place at the anode. So the reaction that takes place at the anode is the anode itself undergoes oxidation and converts into copper cation. So these are the two reactions that takes place at the two respective electrodes, and this is now loss of electrons, so it is oxidation. So this is the electrolysis of copper sulfate solution using active anode and using inert anode. I hope I have made you clear about the electrolysis of copper sulfate solution. For detail, please refer to your book. You can also search in your in NATE. Okay, this much for today, boys. Please do your assignment based on today's class. And I was very disappointed after going through your first open book exam papers. It was your open book exam, but still some of you couldn't take the benefit of open book exam. You can always refer to your book if you have any doubt. Spend your time, okay? Don't rush to submit your answer. You have plenty of time. You are supposed to submit your assignment, that test paper, by 5 p.m. of that day, and you get your assignment by 10:30 in the morning. Please take your time, do research work, okay, and submit your test paper. Please do not rush, but you have to submit your test paper on the very same day. Please take care of this, okay, boys? Stay safe and do all things well.